Hi everyone, today we'll be going through an MIPS assembly implementation of a math matching card game. The game tests players' multiplication skills by matching equations with their results. Let's break down each file and understand how they work together. So basically here we have 5 different files, which name of them would be main, game logic, display, check, and another file that we have which would be sound. So we're going to start with the main, which serves as our program's entry point. So we have different data structures here that we use. That would be, the first one would be the selected pairs, which stores 8 pairs of indices of 4 matching cards. And we have positions, which tracks the position of all 16 cards on the grid. And we have revealed, which keeps track of face-up cards. And we have match, which records successfully matched pairs. And we have remaining cards, which counts unmatched cards. So let's check out the important functions that we have. So the first one would be the select random pairs, which we use an algorithm to randomly arrange card pairs. And after that we have initialize positions, which places card randomly on the game board. And we have like two different functions, set all hidden and set all not match, which reset card states. So the main setup process, it shows welcome screen, records game start time, it initializes the game board and sets up the states and begins the game loop. Then we need to go to another file that we have named game logic. So game logic, which handles the main game loop and player interactions. Here let's check out the game loop functions that we have. So it checks for the win condition, like all cards match. It displays the current game board. It processes the player input from 1 to 16 for card position and 0 to exit. And it has validate moves to check if cards is already matched and ensures input is within valid range. And handles card selection, which first move would be stores the selected card and second move would be checks for the match, and it updates game state accordingly. Let's check out the third file that we have here. So in here we can say that the check, it contains the crucial matching logic that determines if players have found correct pairs. So it has some key features that handle 3 types of matches, as you can see that here. So we have like equation and like equation answer pairs and answer pairs. So it updates the game state for match and increments remaining cards and marks card as permanently matched. It also handles non-matched. It temporarily reveals card and shows feedback message and hides card after delay. As you can see in the code, it just check the equation, check equation answer, and it has check answer that I told you before. So we have two main branches here, which would be no match, that it handle case where cards don't match, and it will show the first card first and after that show the second card and show both cards to the player, and after that hide them again. And also we have another function here, which is match found, that handle case where cards matches and update remaining cards counter. It decremented by 2 for each match pair that found. So the next part, we need a visual presentation of the game board. So let's check out the display.asm file. So here we have 2 types of arrays. The first one would be the regular numbers, as we declare here answers, and the second part would be equations, which we have by 2 by 2 until 5 by 5. So, and we have used ASCII characters for visual formatting elements. And also we declared some parts for displaying the time messages. For each round, the player just reveal the card and after that hide. And also it will show the elapsed time after the game done. Basically, display shows game status like the remaining cards counter, current game time, and match feedback messages, which would be match found or no match, try again. As you can see that we use the display grid function here. That would be the main function in the display file, and also we have another function here would be print revealed card, that it gets card actual position and determine if position is equation or answer, and then after that print equation, or we have another one for the answer. And also we display elapsed time after this part. Finally, sound.asn, it adds audio feedback for card interactions. So we create a 3-part card flip sound, that's switch sound, that's like a paper movement, and a setting sound and a tap sound for final impact. We use as MIDI parameters, which different instruments for each sound component, and it varied pitch and duration and volume control for impact. So, for the conclusion, this implementation showcases several important assembly programming concepts, which array manipulation, random number generation, user input handling, sound generation, time tracking, and state management. The modular design makes the code maintainable and allows for easy feature additions or modifications. Now, let's time to assemble these files and also run this program. First, we need to be sure that we have this check mark here, which assembles all files in the directory. So these all files are in our directory. So we need to go to the main file and click on this button over here and assemble the current file and clear breakpoints. Then we can use this button to run the program, as you can see would be available here. So we use this arrow to start the game. Now it's time to play the game. So welcome to the math match game. It's a welcome message, and then we need to enter 0 to start the game. So we enter the 0 to start the game. So as you can see here would be the remaining cards would be 16 cards over here in bar 4x4 grid here. And this is the elapsed time until for each time that we enter a position of the card or we just start the game. So now let's check the game. So it says enter position 1 to 16 to flip a card, and here 0 to exit the game. So let's start with 1. As you can see, we can hear a sound, and this is the time elapsed like 25 seconds, and this would be reveal the first card. Now let's check the second card that we want to flip. So I choose 3. So it shows that 10 and 3 by 4, which would be 12, and 10 that there are no match. So it says no match, try again, and it just flipped all the cards that are on match. And this is the elapsed time until now, and the remaining cards 16. So let's complete this game and I will show the result. As you can see here, so finally we found a match. The number 2 position and number 6 position would be, this is 2, this is 6. So 2 by 3 is equal to 6. So the game logic works, and as you can see here, these cards are matched, so they're flipped right now, and this is the time elapsed 1 minute and 25 seconds until this move. So now let's continue and finish this game. As you can see, this would be the last card that flipped. So it says match found, you won, and congrats. So this is the total time that we played, 3 minutes and 42 seconds. Goodbye, come again soon. Thanks for watching my YouTube channel video.